Hello and welcome to Geometry, Similarity, Similar Triangles. In previous videos, we've already kind of introduced ourselves to what it means for polygons to be similar. In this case, we're going to focus primarily on triangles. So we are going to be using angle-angle, side-side-side, and side-angle-side similarity criterion to solve problems and prove triangles similar. So what we're going to be doing is determining if triangles are similar using what we know about similarity and congruent triangles, and then we're going to use parts of similar triangles to solve problems and apply what we know about similar triangles to create models and solve real-world problems. These are some of the standards that we are going to be using in this video, and these are the Florida's best standards for mathematics. And then depending on how you want to use this video, you can also use it for some of these thinking and reasoning standards. Let's go ahead and hop straight into angle-angle similarity. And angle-angle similarity is if two of the triangles are congruent to two angles of another triangle, then the triangles are going to be similar. And we kind of hinted at this in another video where we were talking about triangle congruency, and that angle wasn't working because we didn't have enough information, and it really led to the fact that the triangles would be of a different size or could be of a different size. So now once we know that two of the angles are congruent, we can assume that the third is congruent because they all have to add up to 180, and that leads us into angle-angle similarity. So looking at this first problem here, if I were to look at this, notice that we have two parallel lines going on, and when we have two parallel lines, I know that this angle and this angle are going to be congruent because they are corresponding angles. And then from here, I also know that these two are also going to be congruent because they are corresponding angles. And then we have this last one. And if we were writing a proof, an angle congruent to itself, if we're talking about two different triangles here, so if I were to create these two triangles separately and write them out, that is going to be using the reflexive property. And the reflexive property basically says this is congruent to itself. So if you're coming across a proof of some sort and you're talking about angles with these two triangles, that would be reflexive. And it doesn't matter if you named it as angle J, L, and then K for the one triangle is congruent to angle P, L, Q of the smaller triangle. That's going to be the reflexive property. We're basically still talking about angle L. And so based on what we know about angle-angle similarity, or if we think back to what we kind of already decided about angle-angle-angle, these two triangles are going to be similar. Okay, and then let's go ahead and take a look at this one over here. So this one over here, I can go ahead and mark these two angles as congruent, and then when I subtract the two angles from 180, I get that this one is 40, and then from here I have two of the angles that are congruent, and then if I solved for this third one, I would see that these are also congruent, and I only need two of them because I could be able to find the third, so these are also similar triangles. In this third one, we have 90, 60, so this one has to be 30. This one would have to be 60, and then from here, these right angles are already marked as congruent, and then I have those two 30s. I could stop there, but I can also find my third angle here. So these are also congruent. Now this last one is where some people kind of get tripped up. So don't forget how we marked triangles earlier. Anytime you have those vertical angles, go ahead and mark them. So if you need to make a little note to yourself, vertical angles congruent, go ahead and make that note. Now that I have two of the triangles, I can assume that the third ones are also going to be congruent based on what I know about the sum of triangle angles. So now let's go ahead and jump into a more real-world problem. These problems are the most common that come with similar triangles. And so it says a Wi-Fi tower casts a shadow that is 125 feet long. At the same time, Leo stands near the tower and casts a shadow that is 5 feet 4 inches long. If Leo is 5 feet 8 inches tall, how tall is the Wi-Fi tower? Round to the nearest foot. So if we're kind of imagining this, we have a Wi-Fi tower and it's standing straight up, and it's creating this shadow on the ground. And so this would represent the tower, and then this down here is going to be the shadow of the tower. And notice that when they talk about Leo, they say feet and inches. So let's go ahead and just change this all to inches. And so 125 feet, there's 12 inches in a foot, so I'm going to do 125 times 12, and that gives me 1,500 inches. And so this entire piece here is going to be 1,500 inches. And then our question is asking us how tall is the Wi-Fi tower. So this becomes X. Then it's telling us that Leo stands near the tower and he's casting a shadow. And we know that if we're casting shadows, all shadows are going in that same direction. So now let's kind of put Leo here. Okay, and so now he's casting a shadow that is 5 feet 4 inches long. 5 feet 4 inches is going to be the same as 64 inches. And so this piece right here, his shadow, is going to be 64 inches. And then they told us that he is 5 feet 8 inches tall, and so that makes him 68 inches. Okay, and inches. Okay, so now we are dealing with similar triangles where we're having these two kind of parallel lines showing up here. And so now I can either draw this as two separate triangles if that helps me, but now I know that these sides are going to be proportional. So I have 8 goes with 68 inches, and then we have 64 and 1,500. Now remember, I put X as my top, so I want 1,500 to go on the top. I'm putting my larger triangle on the top and then my smaller triangle on the bottom, so 64 inches is going to go on the bottom. And then now from here, all I have to do is cross multiply. And I'm going to go ahead and write it over here so I have plenty of room. So I have 64 inches times X is going to give me 1,500 times 68. And that gives me 64X equals 102 22,000. And don't worry if you're getting extremely large numbers, that's okay. Go ahead and keep working it out and then wait until the end to see if that makes reasonable sense. And then from here, I'm going to divide both sides by 64. And I get 102,000 divided by 64 gives me 1,593.75. Now remember, this is in inches, okay? And I want to go to the nearest foot. So now I'm going to convert that back into feet. And so I have 1593.75 divided by 12. And that's going to give me 132.8. And then remember they said round to the nearest foot, so I want to make sure I have at least one decimal place. That's going to change my 2 to a 3, and so my answer is going to be 133 feet. And thinking about the grand scheme of things, notice that I'm going to take these highlights off real quick so we can kind of look at it. And we want to kind of determine, is this a reasonable answer, right? And so notice that these two are very similar to each other, right? They're really close in number. So I have 68 and 64. Then we will remember that 1,500 inches is the same as 125 feet, and then we're still sticking pretty close when I found out that x is now 133 feet. So that makes sense. If it came out to something like 2 feet or 5 feet, I know that I messed up in writing my proportions somewhere. So you always want to kind of go back and think, is this reasonable? So side-side-side similarity now. This is something we were already working with when we first started talking about similar polygons, and that's basically if all of my side lengths are proportional, then my triangles are going to be similar. So notice here we've got some isosceles triangles, but them being isosceles is not enough because those base angles could be different. So just make sure that you're really paying attention and you're being careful about some of these diagrams. A lot of times they will give you something that looks like this, and then they'll give you something like this. And then people often say, oh, well, they're both isosceles triangles, but not all isosceles triangles are similar. So just be really careful about problems like that. All right, and so we need to look at whether they are proportional. So I know that 8 goes with 6. And then we have 12 going with 9. And our last one would be the same exact thing, so I don't have to write it more than once. Now, we could do 8 divided by 6, and that would give me 1.3 repeating, and then I could do 12 divided by 9, and that gives me 1.3 repeating, or I could use cross multiplication because I only have 2. And 8 times 9 gives me 72, and then 6 times 12 also gives me 72, and so this checks out to be similar. The same thing with our other set of triangles. Make sure that you are kind of aligning up which ones are corresponding. So notice that I have the longest side here is 16. The longest side here is 12. And then our shortest side on this one is 8. And our shortest side on this one is 6. So see how they kind of turn these to kind of trick us a little bit. So make sure you're lining these up right. And then we've got 12 and 9. Now with this one, I don't want to cross multiply, so I'm just going to stick all of these into my calculator. So 16 divided by 12 gives me 1.3 repeating. And then 8 divided by 6 gives me 1.3 repeating. And then 12 divided by 9 also gives me 1.3 repeating. And so all of these are the same, and so these also check out to be similar. If you need more help with writing proportions, please go check out my other video on similarity when we're talking about similar polygons. Alrighty, so our last one that we're going to cover is side angle side similarity. If the lengths of two of the sides are proportional and that included angle is congruent, then the triangles are similar. So notice that both of these have a 70. And then what we're going to do is we're going to say this is the shorter side and then this is the shorter side. So now we're going to test whether these two are proportional. We don't need that third side because we have that angle already set. That means they're not going to be moving around or hinging in any type of way. And then we've got 14 and 21. And 10 over 15 is the same as 2/3. And then 14 over 21 is the same as 2/3. So those two sides are proportional, and then the included side is congruent, so these are going to be similar. And then looking at this one, we have our included angle is that 90 degrees, but not all right triangles are similar, so be careful when you see those diagrams that are asking you about whether they're similar or not. And so we've got to test these two sides here that make up that right triangle. My shorter side for this one is 3, and my shorter side for this one is 6.75. And then we've got 4 and 9. And 3 divided by 6.75 gives me 0.4 repeating, and then 4 divided by 9 also gives me 0.4 repeating. So those also check out to be similar. Now that I know that these are similar, I can put 5 over x, and then I can use these to solve for x. And so from here, I can cross multiply. 4x is going to give me 9 times 5, which is 45. I can divide both sides by 4. And then I get 45 divided by 4, and that gives me 11.25. And so this would be 11.25 if they were asking me to solve. So that's how some of these problems lead into how you would solve for x. And so let's go ahead and do a couple of those problems. So just by looking at the first one, notice that we have two angles that have the same markings. And so they're already going to be similar through angle, angle. And then from here, let's go ahead and create a proportion. So see how 15 is between those two marks, and then 12 is between those two marks. That means that they go together. So 15 is going to go with 12, and that means x plus 5 is going to go with x plus 1. Then we're going to cross multiply. So when I cross multiply these, I end up getting that x is equal to 10, but they asked me to find ED, and so now I have 10 plus 5 gives me 15. If they were asking for AC, it would be 10 plus 1 gives me 11 for this one. So for this one, ED equals 15. So always make sure that you're going back to that original problem to see that you are solving for the correct thing. Especially on the EOC, they're going to put 10 as an answer choice just because they know that you're going to solve for X and then forget to plug it back in. So just be really careful. All right, and then for this one, we can go ahead and mark these vertical angles congruent, and then notice that we have these parallel lines going on here. And if we have parallel lines, I know that alternate interior angles, because if this keeps on going kind of like that, and these keep going like this, okay, K and N are going to be alternate interior angles. So now I have angle-angle similarity with these as well. And then I know that these two are going to go together. So I have 16 and 4, and then 8 plus 18 over X minus 3. And if you need help with writing out your proportions, again, please see my other video on similar polygons. And so always put these in parentheses, and then we're going to cross multiply and solve from there. And for this one, X just happens to be 10 as well, and then it's asking us for LM, which is going to now be 10 minus 3, which gives us 7. And let's do 2 more problems. These are going to be the last ones that we do for this video. For EG, this problem that's on the left, notice that if you need to, you can always draw out your 2 different triangles if that makes it easier for you to kind of see them. So if this makes it easier for you, and then drawing out your larger triangle, if it's easier for you to kind of see it like this, and then having E again, and then F and D, if that helps you out, then do that. And then from here, I have those corresponding angles again. So I know those 2 are going to be congruent, and then I also know that these 2 on the other side are going to be congruent. That's automatically going to give me angle, angle. And then they both have E. So if they ask me in a proof, I'm going to use reflexive on that one. E is congruent to itself. H and F are congruent via corresponding angles, and then G is congruent to D by corresponding angles given parallel lines. So if it helps you with drawing them out separately, that was something that I used to do. It made it a lot easier for me. So now from here, for EG, we have X plus 5, but for our bigger triangle, it's this entire side. And so that means that this one is going to be X plus 5 plus 9. It's going to be that entire thing. So now when I go to write my proportion, I have X plus 5, but then for ED, it's going to be X plus 14. And so sometimes it helps kind of drawing them out separately just so you can see them a little bit more clearly. And then we have 6 going with 12. And then I would cross multiply and solve from there. And once I solve out my cross multiplication, I get X is equal to 4. And then it's asking me for EG. And so that's going to be 4 plus 5, and that's going to give me 9. This makes sense because notice that for these 2 sides, my larger triangle is 2 times the size of my smaller triangle, right? And so it would make sense that G is going to be halfway between ED. So if that one piece is 9, that means this one has to be 9 as well, because EG is going to be half of my larger triangle. So that makes sense just from a reasonableness standpoint. All right, and then let's go ahead and do this last one. So for this last one, if you need to draw it out, then draw it out separately. If that makes it easier for you, just redraw it. So here's my big triangle, and then here is my smaller triangle. And then remember, T's are going to be the same by the reflexive, and then we have these parallel lines, so I know R and U are going to be the same. And then of course I know that V and S are now going to be the same just because they're my third angles. And so now from here I have 14 and 6, so I know that those are going to go together. And then VT is going to be x plus 2, but ST is going to be a combination of these. And so that's going to be 3x minus 3 plus x plus 2. And so that is going to be 4x, and then negative 3 plus 2 is going to be negative 1. And so now I have 4x minus 1 when I add those two sides together over x plus 2. And then I just cross multiply and solve again. And so for this one, I get x is equal to 3.4, a really nice decimal. And then I'm just going to plug it back into SV because that's what it's asking for. And so SV is 3x minus 3. And so now I have 3 times 3.4 minus 3. And 3 times 3.4 is going to give me 10.2. Minus 3 is going to be 7.2, and so that's going to be my answer. And so that concludes our video on similar triangles.